Okay, so welcome to this question debrief on Bellahouston Company. This is the latest sample exam question from the ACCA released for September, December 2021. This one is about limiting factors, and it combines a single limiting factor with multiple limiting factors question. So you've got the scenario here on the left, and we'll move down just to look at the requirements first of all. So the first requirement says calculate the optimum production plan and the resulting total contribution earned for March, assuming that the order with Rumworld is supplied in full. That's 7 marks. And then it says calculate the maximum financial penalty Bellahouston Company would be prepared to accept from Rumworld if it does not complete the Rumworld order in full. So that's a further 4 marks. Now, they've grouped these together under A. So you need to look at those as the 7 plus the 4. Look at those as 11 marks. And you'll be doing that within about 20 minutes. Because what will happen is that you'll do a lot of work in part 1, which will result in getting the answer for part 1 and the answer for part 2 quite quickly, followed on from that. So you may feel it's taking you a lot of time to do A part 1. Do not worry about that. See that as the 11 marks, not the 7 and the 4. Then go on to part B, a discussion on whether Bellahouston Company should fulfill Rumworld's order in full in March. So 4 clear points on that, discussing whether they should or they shouldn't and relating it to the scenario. And then finally, define the variables and formulate the constraints and objective function to be used in a linear programming model to determine the optimal usage of resources in April. That's 5 marks. Now notice it says define the variables and formulate the constraints and the objective function to be used. Do not solve the linear programming. Okay, so it's just formulating those formulas. So let's now have a look at the scenario. So Bellahouston manufactures 3 types of running shoes. Road, which is running on road, spikes, and trail. So we've got road, spikes, and trail. Each of these products use differing amounts of the same resources, and we've got the financial information here. So we've got direct materials, direct labour, machine hours, and then we've got fixed overheads. When we're doing limiting factors, we never look at profit, we always look at contribution. They asked us in the question, remember, to find contribution. So you don't need to take into account those fixed overheads unless they asked you to find profit at the end. And then you'd have to find how many fixed overheads there was. So here we'll just be focusing on contribution. And to find out how many resources they use for each shoe, then you need to take the $5 per metre, divide it into the $7.50, which is the standard cost, to get the amount of meterage that a road or a spike or a trail uses. And I'll show you how to do that in a minute. Again, the fixed overheads is there as a distractor. Then we've got the demand and resource availability. So the maximum demand is given to you for road, spikes and trail. That will be the maximum demand. So you'll be able to use that to find out how many meters of direct material is required for each of the 3 products. And the same for labour and the same for machine hours. Now, Bellahouston is to receive an order from Rumworld. So remember, they talked about the fact that we need to take into account Rumworld. It's not included in these. It's not included in these. So we need to add those Rumworld orders to that. So it's a major sports retailer who has an extensive customer base and are known for stocking the most popular brands of sportswear. We'll be using that narrative in part B, remember. Use the scenario to answer the question. The order is to supply 200 pairs of each type, so we need to add 200 to each of these demand levels. But they have a discount of $8 on the standard selling price. So the contribution per unit will be $8 lower than the normal contribution per unit for each of the 3 products. That is important when we come to costing up the final contribution that we're required to do. Then it says Runwell will charge a financial penalty if the order is not fully complete in March. So this is part 2 of the question. We needed to find out what's the maximum that we'd be willing to pay as a financial penalty if we did not go through with that order. Now note for part B, it says if the first order is successful, Runwell will be keen to enter into a regular supply contract. So that is a point for part B, discuss whether we should go ahead with Runwell or not. In the future, if we do well in March, i.e. we complete the order, we're going to get a regular supply. That's a really important point to make. Now, usually they have enough sufficient resources. However, in March, the maximum availability for each of the 3 is this. So they haven't told us what the limiting factor is. You need to find out which one is the limiting factor. A little bit like in throughput accounting, we find out which one is the bottleneck. So you'll need to find out how many resources is required to make all those demands, plus the 200 pairs for Run Wild, and see if you can compare that to what's available to find out which one is the limiting factor. Then it says demand resource availability for April. This is part C, remember. So they're asking us in part C to formulate the linear programming constraints and objective function using that information. So we'll come back to that when we do part C. So first of all, it's best to define the process. There's 5 here. You find the limiting factor. Then you use the limiting factor to find the contribution per limiting factor. Rank them. Allocate first to Run Wild and then in rank order. And then find the contribution of the optimal production plan, remembering that the contribution per unit is $8 lower for Run Wild. Okay, so let's start with number 1, find the limiting factor. You need to basically schedule it out as it is in the question. So you need to have R, S, and T. You need to write out the selling price so that you can find the contribution per unit. So we're going to have 60. Do this as quick as you can, remembering to be really careful. Then we've got the direct materials, the direct labour, and the machine hours. So we need to pop in the actual costs here. So this there gives us the contribution per unit. Now we need the contribution per limiting factor, but we'll have to find the limiting factor in a minute. So you can quickly do the formula for 1 sum minus the sum of those and then copy it across. So I am in the practice platform on the right side. I'm just not obviously in the practice platform on this side. Okay. Now I need to find the limiting factor per unit. So to find the limiting factor, we need to find out how much each of the direct materials are per product. So basically copy this across to here. And then we don't need the selling price again, but we need to change these to now be units of resources. So I'll top resources at the top there. And this is for contribution over here. So 7.5 divided by 5, just so you know it's $5 here, gives you the number of resources you need is 1.5. And you can obviously copy that for direct materials. Now for direct labour it's $7, so therefore equals 7 divided by. It's best not to use the cell, just put 7 in because you want to be able to copy it across. And for machine hours it's 10. So it's 4 divided by 10 and copy that across. So there you have our resources. All right. So now we need to find out what our demand is that we need for those resources. So demand is 2300 plus 200, remember. So you might as well put them both in at the same time because it includes the run wild. And then we've got 140 plus 200. And then we've got 1650 plus 200. So remember, it includes run wild. And therefore, for the resources, therefore, that we require, we need to simply times the demand by the resources required per unit. So it's going to be 1.5 times by that figure. And if you fix now the green figure with $1, so you can copy that down. And so just check it's still working. And you can then copy that across and hopefully it'll still be working. Yep, it's moved across. So therefore, it's quickly, if you put $1 in and you fix the right cell, or you just have to do it by longhand. So there, the total needed equals sum. So you hopefully see that this is taking a long time, and this is why you've got to work out that this is working towards part A and B. Now we go and see what's available. And available is 7200, so that's not a limiting factor. 6900, again, no limiting factor. So it's going to have to be 1815, i.e. the machine hours, so that is the limiting factor. So highlight that so the examiner knows that you know that's the limiting factor. So we can highlight it. So now we found the limiting factor, we now know which one we're going to be using. We're going to be using machine hours. So machine hours, just pick them up from here, copy them in, and then the contribution per limiting factor is 1 divided by the other. So now we're ready to rank them. So we're on number 3 in my order of things, just making sure you know that this was number 1, find the limiting factor. Number 2, use that limiting factor to find the contribution per limiting factor. So this was number 2. And now we're going to do number 3. And so we're going to rank them. So the first rank is the spike. Number 2 is the trail shoe. And number 3 is the road shoe. So now, remember, we're going to allocate. So remember, that's number 4. So we need to allocate to run wild first. So run wild for road, spikes and trail, they need 200 each. So that's how many units they are. And road shoes take 0.4, 0.2 for spikes, and trail is 0.3. So therefore they require this much resource. If you times them out, then we're going to do it in rank order. So the rest is, the first rank is spikes. And spikes require a demand other than the 200 of 1400, you see over here. So 1400. And then trail, which is number 2. And they require 1650. And then third will be our balance, which will be road. So we need to work that out in a minute. So we're going to find out what we need for spikes. which is 0.2, and trail, which is 0.3. Copy that down. Now the maximum we've got available, we were told, is 1815. So the balance is therefore going towards road. And you need to work backwards. So road need 0.4, therefore available is going to be that divided by 0.4 is what they're going to be able to produce. What they can't produce, just so you know that now, they can't produce 2,300. So they can't produce 2,300 minus that. So 150 pairs of road. Okay, so now finally we need to find the contribution, which was number 5. And so the contribution per unit we've already been given, but remember it's $8 lower for the Run Wild. So for road, it's going to be 41.5 minus 8. For spikes, it's going to be 29.5 minus 8. And for trail, it's going to be 36 minus 8. And then for spikes, the full one for the normal demand and for trail, make sure you pick up the right ones because you're in a different order. And so therefore, we're finding the contribution per unit, and then we've got the total. So make sure you label things clearly. Total contribution. So we're going to times that by the units and then follow it all the way down. And therefore the final answer is total contribution is the sum of all of those. So there's my final answer highlighted. And the optimal production plan is obviously to add those three together. So you may want to just be really careful because you need to know what the optimal production plan is. So sometimes we just need to make sure we're clarifying that. So basically, copy that out down. The optimal production plan is going to be 200 plus that plus 200, and then that plus 200. So we've got the answer which they require, which is total contribution optimal production plan. So I've done that by writing out my plan. Then I've taken everything from the scenario that I was going to use to be able to calculate the number of resources for each to make each unit of R, S and T, and then times that by the demands to get the total required, compared it to the available to find which one was the limiting factor, then use that limiting factor per unit to calculate the contribution per limiting factor and ranking them. Then I've got to allocate, remembering giving it to Run Wild first because that's important, and then the remainder then can go to the rest of them, with the balancing being the third in rank, which is the road shoe. Then that means I can't make 150 pairs of road. So the total contribution I've found by remembering to take the $8 off the original contributions because we're selling them at a discount, and then doing the rest of the normal contributions. Finally telling them what the optimal production plan is. Okay, so that's part 1, and I know that was a lot, but part 2 is now much quicker. So remind yourself, part 2 was calculate the maximum financial penalty Bellahouston would be prepared to accept from Run Wild if it does not complete Run Wild's order in full. Well, what you've got to do is, what can't they make because of doing the Run Wild order? What are they losing out on? Well, they're losing out on making 150 pairs of road. And so the maximum financial penalty is based on the fact that they can't make 150 pairs of road. Now, they're also selling them at a lower price, aren't they? So the $8 discount. So it's not timesing the 150 by the lost contribution. it's timesing them by the 150 by the discount, okay? Because they could have sold them to the external market, not the Runwell market, for $8 more. So although this is the answer to part 1, the answer to part 2, which we're going to put down here, is they basically can't make 150 of the road shoe. So the loss is $8 per shoe due to the discount. So basically the maximum penalty is 150 times by 8, which equals that times that. So the maximum penalty, $1,200. Okay, so we can put that in bold, underline it, everything to make them know that's the answer. So that's 1 and 2 done. So that would be 11 marks. Right, so we're now going to go on to part B, which says discuss whether Bellahouston Company should fill Runwell's order in full in March. If you have a look at your analysis, financially, they're losing out by $1,200. But this part is more about the non-financial effects. So here I now have the word processor where you'd be required to answer this question. So remember it was 4 marks. So we need to find 4 points in the scenario, relating it to the scenario. So remember, if you read here, it says they've got a special order from Runwell, which is not included in the demand estimates. They're a major sports retailer who has an extensive customer base and is known for stocking the most popular brands. And also it says here, if the first order is successful, Runwell would be keen to enter into a regular supply contract. You must use that. Also it says, it usually says they have sufficient resources to meet production. Okay, so they're asking you to focus on the fact that they usually have sufficient resources to meet production. So this might be a one-off. So I know it's financially not profitable to go ahead with the Runwell order for March, but you've got to think about the future consequences, those non-financial factors. So make sure you discuss both sides of the argument. So first of all, on purely financial grounds, in March, BH, I've put for short, Bellahouston, is losing out, my spelling's terrible, which I'm proving to you is okay, is losing out on the 1,200 of contribution, and so potentially should not go ahead. However, the penalty might be more than the loss of that. We are not told actually what it is. This is a very short-term view. So we've put forward the side on financial grounds. So now let's have a look at it based on the non-financial factors. So you've got to think of reputation, you've got to think of that regular order, and you've got to think the fact that they're not actually constrained potentially in the future. It's only really for March and April. And they're also a major sports retailer. So there's all those points to be making. So the first one, they will, however, get reputational damage. If they don't fulfill the Runwell order, other retailers will be reticent to stock the products if they hear about the missed order. They're not normally limited by resources, and so the loss of 1,200 in March will not be repeated and is perhaps a good loss leader to gain a foothold in the Runwell stores. Runwell are keen to enter into a regular order, and so this could bring future profits for a one-off resource issue for March. They are not placing an order in April, but will in the future when the resource constraints will not exist. And finally, they are also a major sports retailer known for stocking major brands. This could catapult BH into more markets and become a popular brand that could actually command a higher price. So those are my 4 points, 4+ points. kind of making sure that I've got enough there to maximise my points at 4. And notice I haven't just stated them, I've explained them in a long sentence. Please don't just state your points. Please don't put reputational damage if they don't fill the order. You don't explain that, have you? So really be focused on how you write and plan the answer carefully so that you get those 4 points out quickly and explained in the right way. Right then, finally, we're going to go on to the final section. And the final section, remember, was define the variables, 1, formulate the constraints, 2, and 3, the objective function used in linear programming to determine the optimum usage of resources in April. So we need to look at April. Now, a lot of the work's already been done when you did part A. So you'll need to flick back to part A to find the analysis that you need. And the best way of doing that when you flick back is to then copy it down on a piece of paper or copy it into the scratch pad to be able to use. So Bellahouston has predicted that the resource availability in March will continue into April, okay? So this resource availability, but it's going to be 15% less in March for the materials and the labour. So materials and labour is going to be 15% less. Machine time will stay the same, and so will the demand estimates. Runwild will not be placing an order in April. Okay, so we have to do the constraints and define the variables. So first of all, you need to define the variables for the linear programming. So it's linear programming. Now you're used to having just 2 variables in a linear programming, but because you're used to having to solve via the graph and then simultaneous equations. But you can still do linear programming with as many variables as possible. You just can't do it graphically, but you can still define them. Slightly naughty question because I think it would have put students off. So you need to define the variables first of all. Write out what you're supposed to be doing. So define the variables. So that simply means let R equal road, let S equal spike, which is already done in your spreadsheet, and let T equal trail. Then you define the objective function. Well, I suppose you could do the constraints if you want to first. So the objective function, but we normally do the objective function next. And that would be to maximize contribution at. Now you need your contributions from your spreadsheet. So you have to move backwards to find them. So what I've done here is I've called up the scratch pad so that I can copy in my contributions. And so I need my contributions per unit. And I'll know that the first one is R, the next one is S, and the last one is T. So I right click, copy, go to my scratch pad, paste. So I've got those in. I also need the constraints. So I need the direct materials, the direct labour, and the machine hours. So I need to get these figures also into my scratch pad or write them down. It's up to you which one you do. And I'm going to paste them. And I'm going to know that that one's materials. So I just might put direct materials in front of it. And that one's direct labour. And that one's machine. So remember, the scratch pad isn't marked. I'm just putting it in there so that I can use it to help me write the answer. So now I'm then going to go back to the word processor. So I now have the information I need to say what I'm maximising contribution at. So I'm going to maximise contribution at 41.5 R plus 29.5 S plus 36 T. Now I need the constraints, and you need a non-negativity constraint. Those variables can't be minus, so they're R, S, T have got to be greater than or equal to 0. I don't think that would matter. And now we've got to write out the constraints. The first one is materials. And so materials is going to be 1.5 R plus 0.6 S plus 1.2 T has got to be less than or equal to the direct materials of 7200 but less 15%. So you need to get your calculator out. And so it's 7200 times 0.85 is 6120. And then we do the same for labour, which is just going to be R plus 1.5 S plus T is less than or equal to, and then we need to take the 6900 times by 0.85, and then that gets 5865. And then machine is going to be 0.4 R plus 0.2 S plus 0.3 T is less than or equal to, and we don't need to change that one, it's 1815. And then finally you've got the demand ones. So the demands are going to be these up here. So R has got to be greater than or equal to 2300. S has got to be greater than or equal to 1400. And T has got to be greater than or equal to 1650. Remember, that's without Run Wild. So that's the answer to part C for 5 marks. So I'm not surprised some students may have found that difficult because they would have thought, oh, we're only supposed to have 2 variables, but now you've seen the question, you should be able to do it. And actually it's relatively straightforward as long as you read the information.